Alright, this is a giant fingertip. Take a second, look at it slowly. This is the fingernail. Comes around, and there's the bone in the back. Now, it has fingerprints just exactly like your fingerprints are my fingerprints, and they are that perfect. And the blood came out of them. Hold on, let me get... Here's the fingerprints. Right? This is what's called grip skin. Different than anywhere else on your body. Totally different. It has extremely dense, fibrous, nasty, scrappy, tough minerals and metals and everything. Now, and they call it keratinized. Well, that just means it's got some really tough stuff. Now, and it's just like a blanket, and it comes off just like a blanket. Now, it adheres to the basement layer down here, but there's sweat glands that go up so your fingers can sweat. There's blood vessels that go up to service the tissue to some degree, not a whole lot. As you'll see, I'm going to show you the blood vessels. I'm going to show you the blood in that right now in the microscope. Well, right not this instant, but this, as you saw, I showed you the fingertip with the other side of it, and here's the bottom. My thumb is approximately the same width as one ridge in a finger. This is not a hoax. This is not a gimmick. DNA, and I've had things CAT scanned, but it really doesn't do a whole lot in a CAT scan. You can see stuff, but you really have to be very, very in tune with what you're looking at. Well, in some cases. In other cases, it's just, there's no question. And I will probably show you those. But I have all kinds of videos on this. Literally, I have, I think, 2,000 videos. And I'm sure 1,000 of them at least are on the Mudfossil discovery. And it was so pushed against. I mean, how many times can you do the same thing? People get mad, well, you keep showing the same thing over and over and over. I said, well, that's too bad. I'm not charging you anything, and I'm not going to refund anything because you didn't get charged. If you went to college, I'd say I want my money back. Absolutely. But don't criticize me for keeping going over and over and over the same thing, because it's just like a class. The guy who does the same class every week or every year or every semester, whatever he's doing. And that's all I'm doing. I'm giving it out, and then a little while later I do it again. I don't think that's unacceptable. All right, as you've seen, there's no way to deny this fingertip and this fingerprint, which is on this fingertip, and it was DNA certified and tested, and it is it's just the one fingerprint ridge is the thickness of my thumb, and there's the sweat glands, and I'm going to show you how I extracted the DNA samples and why it should be considered as completely, so totally valid. And here is the DNA report, and this is was considered dense in that specimen and the lung, and they came out Homo sapien, mitochondrial D and B gene. Now, I talked to the lab. He said 100% it was human DNA, and it said excellent quality was attained from the 36-inch tip and the lung. The 36-inch tip, which is that huge fingertip I just showed you, and the lung, oh boy, it's around here somewhere. But anyway, the lung is, I've shown it a million times. It's a lung, trust me. Anybody looking at it would know it's a lung. So, oh wait a minute, here it is over here. Alright, you just gotta live with it. There's no refunds. Okay, that's the lung. I mean, just look at it. You know, I think this is the pattern of the lobe of the lung. I'm not 100% positive. This is the blood area where I took it out of. I drilled a little chunk out of it, you know, a pin drill out of there. Because that's solid blood. That is literally solid blood on the end there. I could chip this off and take little bits of it and hydrate it and put it in a microscope. Well, here, I did. Hold on. This, I don't know if it was from that, it's not necessarily from that sample, but it is from one of the mud fossils. This is ferrous iron, Fe, and this was the first slide I did to see, can you see that? to see what the size of the blood cells were, because I was trying to these, you know, something like from this and comparing it to something like us, and then comparing it to something like these giants, the gigantic fingertip I just showed you. So I've been doing some work on it. It's not I'm just guessing at any of this stuff. Well, I guess at some of the stuff. I mean, who the hell doesn't? But you know, when I show the evidence I show, you can't deny it unless you're just a denier of reality, and that's what I run up against. Total denial of reality. Very, very concerning. Okay, my wonderful, wonderful friends, this is Roger, Mudfossil University, and today I'm going to present the evidence again that supports everything I've been saying about Mudfossil process and all of the specimens that I have. I'm going to show the support for them, and I'm going to start with the DNA report, which I always show, and it says that they were human, and the DNA was dense. And there was a gigantic fingertip, a lung, and a smaller. But also, all three were human and they're giants. So I'm going to show you the evidence. These are just some little scraps of things that, you know, my goose, I don't mean that, buddy. That's my buddy. But, you know, this is a bone. But what I'm getting at is, it's a process called nucleophilic substitution. Just look it up. It's electrophiles invade nucleophiles, and they match together using transition metals in the middle, and then they stabilize in wet, salty conditions, and then after they're out, they if they're flushed off correctly, they turn into stone. And somehow that happened. I can't tell you how it happened. I'm just saying this is what I have. It's what it is. And this is a goose. And there's the feathers in the back of his head. I mean, I know, I looked at this thing inside out, and I understand all the collagens and keratins that make up the fabric that is membrane, basically, fabrics. And membranes, when I say that, feathers are a membrane. This is a membrane. Tunic is a membrane. Fascia is a membrane. Skin is a membrane. Synovial sheaths are membranes. All of the things that slide in your body, everywhere that there's something that has to be separated, something else is a membrane, and they're all made of the same, not exactly the same mix, but there's a whole batch of different what they call collagens. There's 28 of them, I think they have categorized now, and some of them are very stretchy, some of them don't stretch, some of them are very springy, some of them don't spring at all. They're just floppy and everything. It's just whatever you need for the job. It just pushes one out. I mean, and they all have their own environment they live in, and they all have their own bacteria that supports them. I mean, I'm serious. Bacteria is the key to your whole entire life. If you don't have the bacteria in the right places, in the right amounts, you cannot create mucus, you cannot create the serosa that is the protective immune system. So once you damage your bacteria, and it's throughout your entire body, it's bacteria, every membrane, every single one. It can only let good stuff in and keep bad stuff out. That's its job. If it doesn't do that, you get invaded. All right, so that's just another issue. But what I'm getting at is all of this stuff is validated, and you saw it. Well, let me just make sure you see it. Okay, I got to be real careful. That thing weighs a ton, and it's very unstable. This is the vein side, the black blood. This is a toe, and that's the toenail right there. I mean, that's what it is. Now, this is the arterial side, and like I said, this is the vein side. What happens is they have one comes up and one comes back. Well, actually, this one comes up and this one comes back. The vein side comes back. Now, veins, as I've been saying 1,000 times, they clamp off, so they almost never leak out. This one gushed black blood out of here. I'm going to turn it in a second. We're going to look at both sides. So why did this one gush the black blood out? Well, I can tell you exactly why. Because this one has a huge impacted callus on this big toe. I'll show it to you. And I'll show you the grip skin on the bottom. Yeah, hopefully you can see. Oh, wow, I told you it's not stable. Hopefully you can see that. This thing is heavy too. I'm sure it's loaded with metals, because the metals are in the red blood, and the red blood couldn't escape. So, oh, man, I'm telling you, this thing is heavy. And that's the callus. See that? That's a callus. That's the callus on the guy's foot. See the thickness of that callus? That's what's capping off the red blood. It can't get out. There's still some red blood that comes out here and there, but not like it should. It should have pumped right out of here. Like, you see this little fingertip? That's a little fingertip. That's the red blood side. And the red blood gushed out of there when it died, and it turned into crystals. And I'm going to hydrate that, and you'll see it's still bloody. It's still red blood. And this same thing here, I put water on here. You're going to see this turn red and bloody again. It not leaking blood, but some of them do. This has been sitting around forever. Once they first come out of this ground, sometimes the blood literally runs out of them. I've shown lungs where they literally the blood ran out. I got to watch out for this thing. That's that. It's a little, pad on the toe in the back. Oh, this is a dangerous, dangerous position to be in. All right, now that's the black blood. Never, ever, ever does that run out. Almost never. I mean, never, ever, ever do I see that. And the only reason is because of that impact on the other side. Now, remember, you're going to take your big toe and look on the underside. It has all this scuzzy looking, fluffy looking skin under there. Same thing as this. And here's the blood supply in the back. Now that is the black blood again, and the red blood is over here. The red blood you can't really see all that well because it's just backed up. And this is, you see this fabric here and this fabric running here? They all have what the Greeks used to call it tunica, and it's a wrapping around the bones. It's a fabric wrapping around the bones. You see it running here and here? And this one I can show you in this bone. It has the same thing. Now, you see that fabric wrap right there? You see that? It's a little triangle looking thing. That wrapped right around there and seals. It almost looks like it's sewed. When I first saw them, the way they came together and latched into it, like they hold each other like that. And I said, wow, that thing is sewn together, and it's not. It's the tunica, and it meets and seals itself to protect the bone. And that's what so it looks like a little crescent roll. But everything you have in you has to be separated from everything else. Otherwise, you're just one big ball of gush. That doesn't work. So this bone has to have tunica around it. This toe has to have tunica, and this particular bone in the toe, because that's just the tip of the toe. That's at the very tip of the toe. And the fingernail is right. I mean, the toenail is right to there. Whoops, you can't see that, can you? See, the toenail comes right down to here. That's what it is, and that tunica wraps right around. And that's the callus right there. Now, if you put water on where you see red, bloody looking stuff, it will rehydrate very quickly and turn pretty red again. Now, if I put that in a microscope, you'd see it was kind of red. And down here, you can see it's red already. You don't have to put much water on it to get it red. But water is what's called hydration, and it's hydrogen and oxygen, or water. That's what blood does. It absorbs oxygen, and hydrogen just is along for the ride. And that's why when you put it in there, you see it turns red again. See? And you can scrape this out of here, and this is plenty of DNA in these things. So, if anybody wants to contest what I'm saying, good for you. I was thinking of popping this off because I bet you there's a ton of metals back there. And here's what can happen. Here's a metal toe. All right, this one here, I know exactly what happened. Well, I can show you. Let me show you in the microscope because it'll make more sense to you. The bone is right there. And this was the toe, and there's blood right there. Like I told you, they all have blood running out of them. One side, this side was the black blood, this side was the red blood. And this also, I believe, is a callus here. And there's a reason that they turn into metal. I understand the reason. I'm not sure I want to disclose it, but anyway. I think I already have, but you have to look back for yourself to figure it out. Let's look at this in the microscope. Alright, hold on, let me set it up. Take a minute. Alright, this is that metal looking toe. And here it is up in the microscope, because I'm looking right down at the blood spot. Alright, now, that's just a blood spot. Now, I didn't even wet this. Now, I'm going to turn it over, and I'll show you the bone in the other end of it, which is back here. And that's really all that's left of the bone is right there, right in the middle. That's the bony part in the back where it comes down. I might be able to find a little more. Now, if I mess around with the light, we might be able to see it a little better. Isn't that cool? That's the white little blobs right there that are the bone. That's the remnant of the bone. And believe me, I've looked at it very closely. Well, let's see if we can get a little closer to it and see what we can find. All right, let me crank up the light just a smidge. Now that's just like I say, that was where the main bone part attached. Now, let's drop this right down. And of course, we got to really tune it back in again. See it? That's the bone. That's the last bits of bone. And everything else has turned to basically metals. Now there's all kinds of different combinations of metals in there. All it boils down to is it probably was near a heart or a lung or something that had that really heavy metal chemistry and had a lot of, probably next to bile or a kidney or, you know, something that had a lot of salts or acids. I don't know. But it converted the whole thing into these metallic looking stuff. You see it? Let me turn the light down so you can not get so much flash on that. Let me back out of here so we can see a different perspective. A lot of flash to this. You see that? I'm not exactly sure what all that flash is. It appears to be metals. It doesn't look like it's mica. I'm sure there is some mica in there, but it's primarily metals, I believe, and it's very heavy. So, for its size, you know, I mean, obviously it's small. Here it is right here. That was what we were looking at. Whoops. Right there. That's what we were looking at. And that's the tip of the toe. And that's where the blood supply is here and there. And that, I believe, was a callus, just like the one I showed you a second ago. We might be able to see something right there. Let's take a look at that. Hold on. Oops. Okay, let me turn this light off so we can see. I'm going to look at what I think might be the callus. And we'll see if we can see anything there. And I see it. Hold on. I have an extremely trained eye. There it is. That's the edge. And that is literally the callus that's got on the guy's edge of his toe. And it's like a big red blanket. as you saw on the other one. Now, let me come up with the light a little bit, see if we can see it a little bit better. Alright, so here's the side of the toe. Let me see if I can home in on that. Anyway, that's what it is. Now, that's the side of the toe. And you see how it's layered like that and it has all those red spots in it? That's what a callus looks like. Now, if we go to the bottom, you see that? Totally different. Totally different. If we go to the top, totally different. There's no layering, and you know, there's still red and black blood. I mean, you have blood everywhere, but not like it is on the side. All right, this is on the top. Now on the side here, let's go back to the callus again. Right there. That's the layering, and it really looks like the same callus as on the other one. Looks like there's a little gold in this one here and there. Whenever you got a lot of collection of metals, there's going to be all kind of different metals. I think that's it. Watch this. When I turn this down, then you can really see the difference in metals. You see them start to show up. I believe that's gold. These little ones here, the flake is over there. That's the bone right there. It's still sort of round. And that's the artery. It's turned into glass, which is crystal because it's empty. And there's the vein. And that's the last of the bone on this one. Stuff is absolutely amazing. You know, the diversity is just absolutely incredible. Okay, my friends, I was told that these things can't turn to stone, and I showed all this, and I have all kinds of proof, and I've shown you a proof by now, I'm sure. You know, it can turn right into meat. I mean, meat can turn into stone. Now, and also fingers have the blood, and the blood squirts out of the arterial side. Now, they say, oh, that can't be a finger. I say, yes, it is. Let's take a look and see what a finger looks like. I say that's exactly like the finger, or any academic might be able to decide if it is or it isn't. You see it? I say that's a finger. What do you think, guys? And let me show you what the blood looks like when it runs out of the arterial side, not from the vein side. And then we'll see if we can find the artery and the vein down in the back. And there is the crystal structure. And blood turns into, literally into transition metal crystals. It's absolutely fabulous to investigate when you know what you're doing. All right, let's take a quick look. All right, here's what happens with your fingers. On one side, it comes in with the artery, and then it filters all through there, and it goes back through the vein. And two of them tie together, vein to vein, into one little hit down here. And the same thing here, artery to artery. So it's one goes back, and one goes back, and one goes back, and it feeds two. I hope you understand that. So in the thumb, look at how dense the blood is in the thumb. Look at how dense it is in the end of these things. Now I'm going to show you what happens at the tip. There's like two holes here and one at the tip. And I'm going to show you a very extremely eroded fingertip that has those holes in it where the artery blew out, and it has the plugged off holes where the veins were, and it has the end hole, and it's got the pattern of what they call the distal phalanges. Let's take a look at that. All right, this is going to probably be hard to see, but that's the tip of a distal phalanges. That's the tip of a fingertip, and that's the bone black. Now, you can actually see in the right light, you can see the pattern of the bone where it comes down. That's really the bone. Now, all the flesh is basically eroded away. That's the distal phalanges bone black, because that's where the marrow is inside, and it leaks through this mud. That is the artery side that stays totally open. That's the vein side that plugs off. You see here? It blew right out the side. It blew right out, both of these, boom, boom. And then it blew out the end too. That's where blood of the arterial side just explodes right out. There's no restrictions to it. Now watch this. This one here is on the other side. It's the vein side. You see that? It clamps off. It clamped off up here too. There's another one right under there. You can't really see it. But there's the one, and then the other one is right here. And at the end there was one too, and that's clamped off too. They have exactly the same on this side as this side, and in between is all the little blood vessels. And that's why COVID toe is like just like this, only it's at your toe. So all of the heaviest stuff filters down and is getting clogged up here. I believe that's the case. Now, they should investigate that, because I know what happens in the COVID. The COVID attacks this very elastic, well, not elastic, it's like almost like a spring that's in the areolar tissue and the interstitium. And once it breaks, it can't open back up again. Now, I was talking to a friend of mine who is he's a director of Fascia Institute in Germany, and he told me, because I didn't know if those little breaking things would get through your blood system. And I'm thinking to myself, well, they're probably going to just get stuck in those bags. However, listen to this. I'm talking to him. We had a very long conversation. We're going to do some research together. And anyway, what they discovered was that the interstitium is not a sealed bag. So those little fibers can leak out of there. And I said, how do you know that? And he said, well, they did a study on tattoos. And I said, well, what does that mean? And he says, not the fibers, but there's a certain chemical in the tattoo, and they put the tattoo right into your interstitium layer, in those little things, and they found it floating throughout the body. They found it in your organs and everywhere else. Now, I don't think it causes any trouble, because people get all kind of tattoos. I don't think they have any issue with it, but it's some kind of a molecule that adheres to things, or well, I don't know. Well, it obviously adheres to your collagen right up in this area here. And apparently it gets in and floats around, and if it catches more collagen that is interstitium and it locks there, that's where they found it. So in other words, my point being is that that's broken little bits and pieces are not stuck in those bags. I believe they're floating through your body, and just natural specific gravity, they're the things that are going to end up being at the bottom and trying to get through to come back to your heart. Can't do it. You're stuck. And then you get that COVID toe, and it's nasty looking stuff. So anyway, arteries, veins, blowout, stuck. Case is closed on that. And that's the proof, and this is the double proof. And that is the distal phalanges. What you need is what we really need is a panel of people that do all of these different things, because I do all of them. I do every single one of them, because you can't do one and not do the other. You know, if you just sit there and say, I'm an expert on fingers, well, that's good. But if you're an expert on fingers and blood supply and tissues and chemistry and, you know, anatomy and all the other things, well, that's better. And that's what we need. We need a whole crew to be on internet. Now, I'm hoping I got a guy that will maybe do this, but here's the key. I never wanted any money. I still don't want any money. I don't need any money. I did all my stuff already. I'm done. I don't have no need for money whatsoever for me, and I don't want any, and I don't want to be put in that realm where I look like I'm looking for money. However, we do need people that need money. That things are tough for a lot of people, and if somebody's going to step up and put a lot of time and a lot of effort, and we're going to need some money for, I don't know what it's going to be for, to be perfectly honest with you, but if I find somebody I really trust And he's willing to do, or whoever it is willing to do a platform where we can have discussions basically daily and have interaction of hopefully experts. People don't have to be an expert to ask questions and interact, because nobody's an expert right now. I'm telling you right now, there's nobody who's an expert. It's just brand new. Where's the experts? They're the ones that are saying, no, this isn't true. Well, I'm telling you, it's true. And we need experts now. Now, wait, don't forget now. I have something that the experts should have to look at right now. Remember I showed you all this stuff and all the blood coming out? Well, that one there is the fingertip, as I showed you before, I believe. And don't forget, make sure the experts are looking at that. It's just like this. You see it? It's just like that. Has every expert seen this? Now, that's the blood coming out of the arterial side, but not the vein side. So, trust me, it does it. Now, we're going to look at it. It's in the microscope. Now, let's put a little water on that puppy. And then we'll go back and look at it in a second here. You see that down the end? That's the blood coming right out of the very tip at the end. Now right next to it there is the black side. Nothing coming out. The red side is bubbled right out of there, you see? That's the artery side. Now it didn't have to blow out of the sides because it was so easy coming out of the end. Now it ran down around the front. You see this right here? This is what happens to blood. It congeals just like it does on you. And it forms, in mud fossils, it forms crystals. You see that round thing in the middle? That's where your tendons lock in. It's just, it displays a little bit. But that's all red blood that ran out of there. All right? So it died laying down like this. And this is the fingernail side. Alright, I'm going to show you the giant fingertip in a second. This is the DNA report for all three of the items I had done. And I'm going to show you a couple of, well, I'll show you all three of them right now. But it was, they were all positive for human DNA. And it was excellent quality DNA. It was obtained from a 36-inch tip, which I'm going to show you in a microscope right now how I got that DNA. And from the lung sample, which I will show you how I got that DNA. And here it is right here, Homo sapien, mitochondrial, cytochrome B gene, and D-loop region. Both of them, well, all three of them tested for this. These two were the dense ones. The other one was a real true mud fossil. These had good blood still left in them. I mean, good blood. And it was all certified and verified by the lab director. Now, I was the one that extracted the samples, and I will show you how I extracted them. And he says he will stand behind what he did, what I presented him. This is the results. If I was lying or I didn't do something right, well, that's a different issue. But two dense things, and I'm going to show you how I did it, because you'll see it. When I show you what I can get out of these things, you will freak out. Alright, this is the sample that I am going to be showing you in the microscope right now. That's the fingertip. And on the other side is the fingerprints, which I'm sure I showed you, or absolutely will show you. Now here it is in the microscope. So let's take a look at what we got there. That is red blood, which is the artery side, and that's the vein. The veins plug up. That's just the nature of vein blood. Is supposed to clamp off so it doesn't go backwards. The artery just goes anywhere it wants. That's why you almost always find them open. Now this is the fingerprint that I took off of the fingertip. The fingernail is on the other side. Now, from here, I went up inside the finger, the big finger, and I drilled out some blood. But when I put some water on there, you'll see it's going to, I hope it turns red, and it should. All right, I just put a little water on there. That's the vein side clamped off. That's the artery side. And let's see if we can penetrate down in there. let's see. Let's play around with the light. Sometimes the light makes a big difference. All right, we can see down in there? That's an artery. That's red blood. And what I did was I went up inside the fingertip and took the red blood out. It's just red blood. That's all it is. And this is black because that's the vein side. And they clamp off. I've said it a bazillion times. And this is grip skin. You see all that really heavy-duty, raspy-looking stuff? That's what's in your skin. When I show you the grip skin, well, I will. Let me show you the grip skin right now. I think if I escape from full screen, there it is right here. All right, that's what, whoops. This is what is in your grip skin. In addition to that, it has all that other stuff that I just showed you right here. Now this one, the giant one is, I have this other one here too. This is from a different, this is a toe. You know, that's funny. Maybe the toe has different fibers than the finger. That's interesting. I didn't have to look into that. Because the fingerprints have what they call grip skin on it, but so does the feet and the toes and all that. It's where you rub against surfaces that you have grip skin. And, very interesting, because here we are here. It does not have that same characteristic. Let me back way out. See, discovery every day, my friends. Discovery every day. If you don't pay attention, you never discover anything. Now we're way up high. I don't know if we can see anything. It's pretty high up here. It's certainly not the same kind of grip skin. Now we're going right on top of where the skin is. No, that's underneath of the skin. That's the underneath of the skin, you see it? Now here's the top of the skin. And it's just gritty and tough, raspy. This is a little piece of the fingerprint right over here. And that's a sweat pore. You see that little spot right there? That's a sweat pore. And that's what skin looks like when it petrifies. Very, very, and not grip skin, I'm sorry. It's not just skin, it's grip skin. Now, but it is similar to all the other things that petrify. This is the goose head. You see that? That's just almost the same looking sort of stuff. That's feathers. That's from feathers. Everything that's the fabric of life has that black, white and brownish, reddish looking fibers to them. That's the goose's head. And back here, this is where the feather pattern latches in. You see this here? That's the overlap of the feathers. Wonder if we could see anything way, way down close. Let's go right down to the bottom. I gotta turn the light down. And we gotta do a little focusing. I can see a little bit of a pattern there. Let's see. All right, that's the tip of the feather right there. That's the tip on the back of its head. It's laying like this. The head is facing forward. So this is the tip of the feather. Now, let's see if we can home in. I believe I can see the edge, because feathers have this little ripply edge on them. And I'll show you, I have one here, and I'll show it in the microscope in a second. So here's the edge of the feather, but that's that little ripply edge as it lays over into the next one. That helps them to fuse together. Like, there's the tip of the feather right there. All right, now, there it is right there. There's a good shot of it. That is the fluffy stuff that comes off the edge of the feather. Now let's look at a regular feather. All right, yeah, I see the same pattern, the exact same little fluty edge on the edge of the feather. So that's how they edge out, and that's how they could like fuse into, because this is one actually should be fused together. That's how what they use to sort of mate into the other feathers to make a nice mat of feathers. All right, this is kind of tough. It's a real wobbly. This is the goose's neck now. This right here has something to do with the vertebra, I believe, of his neck. Now, I'm going to come over to where there's some blood way up here. Is where the artery is. I'm going to bring it down into that area. Right up in there, there's some red blood. And we'll have to come down there and look at that close. If we turn up the light, might be able to see a little better. Oh, you know what? That's what's going on. I knew something wasn't right here. All right, here we go. Now, right over here. I'm gonna have to focus it, so don't get concerned yet. Right up in this area, there's some blood supplies, I believe. Let's take a look. We gotta do a little focusing. Let's come down close and look. Because I believe it's right up in this area where the blood supply is. And if we mess around with it a little bit and we come up and down with the light, and we come up a little closer, we'll see it. But these are all blood vessels. See, this is where the feathers came over the back and hung over. And that's basically the throat right there. And whatever, these are blood vessels or nerves or whatever they are. And if we come down close, you'll see there's all little blood vessels around here and there. But there's a main artery. I believe it's right up in here. Let's see if we can find that. Let's see here. Yep, there it is right there. Oops. Right there it is. That's the main artery. Now, mess around with the light. Again, it's real movie because I can't really, it's so out of, I can't lay it flat. Let's just go with that. Now, let's watch this. Keep your eye down in that hole. You see that? You see that? All you have to do is get down in there and take a little, clean it up good, and then just drill right out of it or scrape out of it, however you want to get it out of there. Now, if I put a little water in there, that should hydrate it a little bit. Let me put a little water in there. Hold on, I gotta dry it up. Let's see what we got here. In a minute or two, that'll start to be pretty red in that scrapey spot. You see the scrapey spot? I just did. I scraped this right over here. Boy, I wish I could stabilize this. Hold on. Now, this is better. All right, here we go. I mean, you can see how obviously round it is. And I scraped down in the, literally that's blood. That is literally blood in there. And if some of it flowed out of here, as you can see, but that's where the blood came from. Now, everything has to have blood. Everything has to have tissue and blood, and tendon and muscle and all that stuff. And I have shown all of this stuff. Now, that's a cavity. Watch. I don't want you to get confused. This is the top up here. You see it? That's a cavity going down in there because it's a artery. And I know it's an artery. It's not a vein because veins seal up. Now we can drift way down inside and look and see what's going on deep inside that thing. And if you just scraped this whole top off and then drilled it out and sent that away, you know, you got to follow some basic, obvious, you know, put a mask on, use gloves, just, you know, but everybody that I talk to thinks I'm just scrubbing something off the surface and sending it in and saying, what do you think this is? And I'm drooling all over it. And I mean, you wouldn't believe the things I hear from people. Absolutely insane. This is the neck, where the neck folds over. All biology, my friends. All biology. All of this here is where blood vessels are going in and out of that neck. Boy, this is hard to jiggle in and out and get nice and clean shots here. I think that's about the best I'm going to do. But all those little divots looking things, that is blood infusing up into the neck. That's my buddy. That's my buddy. Here's his beak. Your beak doesn't look any different than the feathers. You see, that's the tissue of the beak. Now, there's a little hole in his beak, his nose hole, or whatever it is. All of this stuff can be easily looked at now and verified one way or the other. That is mud fossilization, my friends. Rocks don't just have veins and arteries in them and all of that stuff for nothing, trust me. You see that? There's an artery and a vein right there, you see? There's the arterial part, and that's the vein. The vein is black, the artery is red. And they're all over the place. It's not just one here and one there, and that services everything. Hell no, they're everywhere. You got veins and arteries. Because every single cell in your body is continuously in a state of instability. Like even here, over here, you see? They're all over the place. I could find a million of them if I look around. But I look for the good ones, the big ones. And that's where I take the blood out. Like the big one, that was the best. A ton of blood. And it was dense. Well, no, this was, I never had tested this. But the other ones I test, I show you the fingertip, I think I did already. But see way down in there? That's blood. And there I scraped. Remember that was like really whitish looking a minute ago? Well, it takes a little while for it to hydrate back in. But I tell you what, if you sent that off for DNA, it would be saturated with DNA. It's red blood. All right, in addition to the giant fingertip, this lung, normal-sized human being, found in the same area on the surface, well, actually they're on brick walls, I'm on stone walls. I've got a ton of stone walls around my property, and I just really went around and picked them up. This is a fingertip, same thing, had this tested, DNA tested. That's on this report too, human, and the giant one that I showed you with the fingerprints, human. All right, you've seen the things that I've discovered. They're just nobody's ever considered them to even consider them before. So now this is all new. But I've been working, not really working with Frank, but I've been following him because he's the only guy I know that is this deep, and I don't know if he is completely into the Mudfossil end of things yet, or he's following academia, what they're talking about. I don't know. I haven't really paid that much attention because I've been focusing on the material stuff. But now that the material stuff is so overwhelming, I need to get into the, what does it mean? Who were the gods? Because now I'm very serious about, there were gods, there were powerful ones, there were less powerful ones. They created all kinds of monsters and serpents and dragons, and it all has to be investigated. Now, Frank is, what you should do if you want, it's up to you. He's only got 245 members, ancient Japhetic nations, and these are the earliest Noah and all those guys. So you should come up here and hook up with Frank, and he's very interested in conveying this information. He's not just a guy that wants somebody to come up there and say, "Oh, you're a nice guy." Here's what he's got all kinds of things going on. I told him I was gonna. He had put in a. Let's see if I can find it. Hold on, I don't want to keep you up all day here. Here it is. No, just watch here. You can just go back to this if you want. But this is Frank's email and everything. And he says you may give my email, you wish, any questions, and he wants you to be critical and look through his information. He's going to send information. Let me see. Well, anyway, that. We're going to get into the meaning of these things, because it's interesting that these things are here, but yes. But what's the story behind them? That's where I want to go next. So stick around, and like I said, if we can get a forum going, because otherwise it's just nonsense right now. There's so many people claiming so many things, and they have really no idea what they're talking about. I did a lot of work. Now, if I'm wrong, I'm wrong. But if I'm wrong, I want to be proved wrong, not just say, "Oh, the guy's stupid," or "Oh, that's crazy, you can't turn this to stone," or "Oh, you can't get DNA out of a stone, you can't do this, you can't do that." Well, yes, you can do all the things I'm saying you can do. And if you can prove me wrong, good. That's what I'm here for. I have no issue with that whatsoever. But to just dismiss and denigrate and demean is from the ones that are supposed to be investigating and the search for truth, which is the academic universities, the top universities, Yale, Harvard, all of them, every single one of them. I contacted literally every one of them, just about, and I contacted not just one person there either. I contacted a ton of them, and no response whatsoever. So, in my opinion, academia has fallen. And we have to pick up the slack. So we're going to start with an online forum. I did just talk to the guy that I was talking about. Hopefully we're going to be able to get a basically daily interaction. I could go all day long as far as I'm concerned, because I'm not going to do it all myself. I'll answer a lot of questions. I'll present a lot of. I have literally thousands of specimens and things to present that. I mean, I could blow your mind every single day, and everybody says that. I can't imagine how you keep coming up with this stuff. I have it. I got tons of it. I still got tons of it. And I'm not going to grab it. I was going to grab something and knock your socks right off again, but no. Let's get a forum going. All right, but somebody may have to put up a little money. Somebody might have to kick in a few dollars here and there. I see everybody asking for money. I don't want it myself, but I'm one of the rare ones that I've already taken care of my needs, and I don't want to get into that realm. I just want to be free. And once you're in the realm of getting money, you're not a free person anymore. Money overrides your freedom, basically, unless you can. I don't know. You know what I'm saying? If you can't, and that's what happened with these professors and so forth. They cannot speak, and I understand that. I'm giving them a pass. You have a pass, my friends. If you turn yourself around now, you have a pass. Because it's so hard to, and it was shut off by Yale. Yale's the one that does not have a pass. I give them no pass. The rest of them, I give them one shot. And if they don't come around, boom. I mean, it's over for them anyway, as far as I'm concerned. Because at this point, they have no clue about anything. They have to come to my school before they can even become less than an infant. I'm serious. They're infants now. And the smarter they are, the more infantile they are. Because they become like aggressive little infants. I'm sorry. I know you're in a bad spot, but if you turned yourself around in the beginning and said, "Ooh, this is interesting, we have something to learn here," no, it was exactly the opposite, and that I cannot tolerate, and nobody can tolerate it. So, you had your chance, you blew it, baby.